I'm going to quickly introduce the team that we have on the call with us today. So, hi everyone, my name is Edmund Munday. I'm a senior product manager on Bitbucket Cloud. I look after a few teams in Bitbucket Cloud. Primarily, the teams have been building out this new exciting capabilities we've been building on Forge, as well as the teams that run our Bitbucket Pipelines product. Joining me on the call today, we have Ash Musa, who is a product marketing manager for Bitbucket Cloud. And we have Katarina Kurti, who is one of our developer experience evangelists. I'm not sure if that's the correct term, but she's a passionate fanatic of all things developer experience across the Atlassian platform. So they will be participating, answering questions in chat, and hopefully we can get you all the information you need. All right, let me find the button to share my screen. Seems to be eluding me for some reason. There we go. All right. So I promise not to bore you to death with slides to start with. So we've got a couple of slides just to introduce what we're talking about today, provide some context, and then we're going to dive into a live demonstration. So welcome to the Customizing Bitbucket Cloud with Forge webinar. This is going to be the first of a series of webinars we'll be running over the following few months to introduce and dive into some really exciting capabilities that we will be bringing to Bitbucket Cloud over early 2024 and then extending all throughout the year. So what we're going to be talking about today is a high-level overview of what we're trying to actually achieve with this push into extensibility for Bitbucket Cloud. We're going to be talking about Forge, which is Atlassian's extensibility framework that has been designed to apply across all products and that we've recently implemented inside Bitbucket Cloud. We're going to be talking about what you can do with Forge and specifically what Forge is going to allow you to do inside Bitbucket Cloud, what kind of problems it's going to allow you to solve, and how we're approaching the Forge framework a little bit differently in Bitbucket Cloud to how you might have heard about it being used in other products, with a stronger focus on how it can be used by our customers and our everyday users. And then finally, we're going to build something really simple, and we'll go into details about that at the end. So why are we talking about extensibility at all? There's a million things we could build in Bitbucket Cloud. It's a very powerful product and it does a lot of different things. So why extensibility is that something that we're focusing on? Fundamentally, extensibility is a capability that allows you to make a product flexible. And a flexible product is, in my opinion, a good product. The number of use cases that you could possibly need to get out of a CI/CD and a source control management solution is extreme. And the reality is that those use cases are going to be quite bespoke and quite often very nuanced to your particular company, your business, the way you work, your industry. And so realistically, the ability for a single off-the-shelf SaaS product, no matter which product it is, to perfectly meet every single one of your nuanced business-specific requirements is quite low. And in fact, you probably wouldn't want a product that could do that because to achieve that, it would have to be so complex and so configurable that it would approach unusability. So we're taking a slightly different approach to this problem. What if you didn't need a product to solve every single problem you could imagine off the shelf? What if you could actually take a product that solved the core set of use cases in a really nice, user-friendly way, in a powerful way? Things like code reviews, things like pipelines, things like managing your source code. But then at the edges where you needed new functionality that was bespoke to your business or say industry specific, you could actually add that yourself in a really simple, easy to implement way. We're in a really exciting position with Bitbucket Cloud in that we know that the vast majority of our users write code every single day. So code is not a scary concept to them. In fact, for a lot of our users, for most of our users, code is actually their preferred way of interacting with the system. So we're looking to embrace that and give our customers the ability to make the Bitbucket product do what they need it to do in the areas they need it to do it. This isn't a particularly novel concept. Like, you've had this capability with a lot of on-prem DevOps tooling for quite a while. The idea of plugin-oriented tools is not new. You see that with Atlassian's own on-prem products. You see that with most open source tools. This idea of user-created plugins to add new functionality is a widely adopted pattern, and we know it's successful. But you don't really see that in a cloud environment, in a SaaS environment, because there's a lot of inherent complexities involved in making cloud multi-tenanted SaaS tools extensible. And that's what we're talking about today, is how we're looking to leverage Atlassian's Forge extensibility platform to bring those kinds of flexible plug-in architectures that you're used to with sort of traditional or open source on-prem tools, and bring it to a cloud SaaS DevOps solution inside Bitbucket Cloud. So the core capabilities that we're talking about today are based on top of a solution that Atlassian has been building out over the last few years called Forge. So Forge is effectively a we'll call it a light touch platform as a service solution that Atlassian has built primarily to support our app marketplace partners in building apps that customers could purchase from our app marketplace and install into their products. You're probably familiar with this concept. There's a good chance that in your organizations you have you implement at least one or more marketplace apps. I think on average every customer has at least one marketplace app installed in their instances. So you're probably familiar with this concept. In Bitbucket Cloud, though, we're taking this concept and we're putting a bit of a different spin on it. While we're absolutely going to be catering to our app partner ecosystem, we're also going to be focusing heavily on our customers as users as well. We see Forge in Bitbucket Cloud not solely as a tool for app developers and marketplace partners, but as much it will be a tool for our customers. It will be a feature of Bitbucket Cloud itself. The reason we can do this is, as I mentioned before, we're in a very advantageous position in that most of our users code every single day. And so the ability to extend the product, even in simple, basic ways with code, is extremely powerful and something that we believe our users and our customers will get a huge amount of value out of. Forge enables app developers of any type to quickly and seamlessly create new capabilities and add them into the product. This includes backend logic, front-end UI, and any other component you can think of an overall end-to-end experience, including persisting data, making API calls to other systems, whatever you need in order to add that new capability you want to the product. It's a sort of batteries included framework. It provides literally everything you could need to get started, including an off-the-shelf UI library, like truly zero operational overhead hosting. So you don't need to worry about hosting a server to put your logic on, or hosting anything to serve your front end from. The Forge platform handles all of that. You literally run one terminal command, Forge deploy, and you're done. We look after all of the heavy lifting for you. As I just mentioned, it's sort of single touch deployments. You run a single terminal command. It feels like you're actually running everything locally, but you're not. It's running inside our platform. It's that simple. And for me personally, the most powerful feature of Forge is that it completely removes the complexity of authentication and authorization for your apps. So if you ever tried to build integrations or automations in the past, I am sure that you're familiar with running into the complexities of authorization and authentication. Now, there are simple ways of handling that, such as using API tokens, but they're not the most amazingly secure solution. You don't really want to be storing tokens in places and sending them around. And then there are much more secure solutions like OAuth and OIDC, but they're complicated. You have to set up, OIDC clients, you've got to manage secrets, and it is a complex process, which means that the barrier to entry is quite high, and it's only worth building these things if you're going to be solving a really large problem. The beautiful thing about Forge is it completely removes all of that complexity for you. We deal with all of that complexity of the authentication authorization. We implement a highly secure form of authentication authorization, but we abstract away all the complexity. So you don't have to think about it. We do all that for you. And so I refer to it as sort of invisible auth. And in my opinion, it's probably the most powerful capability that Forge provides, because it means that it now makes sense for you to spend a few hours knocking up a quick automation or extension to solve a problem that your team or you personally might be facing, because you don't need to spend 3 days building an OAuth client anymore. You can just write your logic and deploy it, and away you go. And we're going to show you exactly how fast it is later on. So why are we using Forge? Why have we gone down this path? Why do we think this is a thing that we should do? So Forge was originally designed to empower our third-party app partners, as we mentioned earlier. And it's designed to be the simplest and safest possible environment and platform to build apps within for the Atlassian product suite. Like I said, in Bitbucket Cloud, though, we're taking a different approach. So instead of this being solely for third-party app developers building marketplace apps, we're leveraging this to provide customers with features as well. We are also taking, I guess you could say, a slightly more opinionated view and slightly more opinionated approach to Forge. When marketplace partners build apps with Forge, they tend to be quite open, they're quite flexible. They can add front-end UI components wherever they like. They have backend logic that does whatever they need it to do. We don't provide a really strong sort of opinions as to how they should build those apps. There are a few exceptions though. There have been some areas around different products where we have been a bit more opinionated and said, we are going to provide you a very specific place to use Forge to solve a very specific problem. And one of those examples from products outside Bitbucket Cloud is Jira Workflow Validators. So you can use a Forge function, which is basically just like a little Lambda function, to operate as a custom workflow validator for Jira workflows. That is obviously much more specific than just allowing you to build an app which sits somewhere inside Jira and does whatever you need it to do. And that's kind of more of the approach that in Bitbucket Cloud we've been taking with our Forge implementation. We do have the standard sort of, I guess, what we call vanilla Forge extensibility, where you can add your own UI, you can add your own backend, you can add data stores, and you can do whatever you need to with that. But we're also adding a series of more opinionated extension points, which is designed to solve really specific problems that we know customers have. And fundamentally, they're designed to allow customers and users to hook into the underlying business logic that runs inside Bitbucket Cloud and augment it with your own business requirements at really key parts of the workflow. I'm going to go into details of some of those examples in a minute. But the main thing just to keep in mind is that when you're building these things in Bitbucket Cloud, they are designed to be somewhat opinionated, and that is so that they can be simple, so they could be clean. So you don't need to think about all the other externalities. You can just solve one particular problem at one point in time. But those problems you're solving are more categories of problems, not single specific problems. I'll go through what I mean in that in a little bit more in a second. Now, this is a very novel approach to extensibility in a cloud DevOps tool. Competing products on the market provide sort of relatively basic extensibility requirements through things like, APIs and webhooks, but they don't really make extensibility a core pillar of the product. They see extensibility as a way to integrate with other systems, but it's not an actual key feature of the product itself. And that's something that we want to position ourselves differently of. We want Bitbucket Cloud to be the extensible product that you think of in the market when you're thinking of tools for managing source code and tools for managing CI/CD workflows. My slide deck went the wrong direction. Sorry about that. And that leads to our vision for all of this capability. So we have a vision for Bitbucket Cloud to be the most extensible code management and CI/CD product on the market. We want to, over the next 12 months, we're going to be releasing a range of new capabilities in line with this vision. And what our goal is to allow you to use Bitbucket Cloud as the foundation for your own sort of DevOps platform. So I'm sure all of you have some kind of DevOps platform, whether that's a simple set of CI/CD workflows or some bash scripts that you run on a machine to deploy your service via FTP, or hopefully something a little bit more comprehensive than that. But you all have some sort of system and some sort of workflow that you use to run your DevOps processes. We want Bitbucket Cloud to be the logical home for those platforms. We want it to be a system that you can build on top of. So you don't see Bitbucket Cloud just as another product in your kind of line of different tools. It is the foundation that your entire sort of system is built on top of. And we're going to enable you to do that in the way that works for you through all of this extensibility. So I'm going to be diving into two specific examples of ways that we're adding extensibility into Bitbucket Cloud now. Now, these are just the first two that we will be releasing. There'll be a series of additional extension points coming over the following sort of 12 months and probably longer. What I'd like to say, though, is that we really want your involvement in this process. We want your feedback. We need your input. We want to know what kinds of things you would like to be able to extend yourself. We've identified a few of the kind of really critical ones already, and we know that there's a lot of value in these. And Atlassian is actually using these internally already to great success. So, but as we go forward, we really want you to get involved. We want to hear from you to understand what you want. And I'll be sharing a bunch of links before I get into the demo of ways you can get involved. I don't know why my slideshow keeps going back one step every time I go forward, but anyway, Google Slides, everyone. All right, so the first example is custom merge checks. Now, custom merge checks is a capability that we shipped into open beta just before Christmas. So what are they? You're probably familiar with, I guess, what we would call classic merge checks or standard merge checks, and their capabilities as part of the branch restrictions feature of Bitbucket Cloud. They allow you to implement rules that basically will prevent code from being merged into a repository unless certain conditions are met. But today they're quite static. There's a list of pre-built rules, maybe I think like 6 or 7 rules that are baked into the product that have some basic configurability. say, for example, how many green builds must you have on a PR before it can be merged? How many reviewers must have approved a PR before it can be merged? Things like that. They solve a lot of use cases, but they are quite broad kind of by nature. Custom merge checks is the idea of allowing you to write your own business-specific merge checks that allow you to implement rules that are catered to your business's requirements, not a generic rule that caters to everyone's. They're very simple to write, and they are implemented as part of the pull request workflow. They show up in the UI as if they were a native merge check. So the experience for your developers and they're doing the PRs is as if it was built by us, but they're actually underneath. They're a Forge app that you've built and you've deployed into your instance. You can use these to implement literally infinitely comprehensive rules that your business can require, and then have them configured against the repository. What's more though is once we go into general availability with this feature, the next major capability we're going to be adding to custom merge checks is the ability for you to configure schemes and policies of rules at the workspace level. So you will be able to set centralized sets of rules and policies around things like security, compliance, workflow for the whole company, and then inherit those down to every repository in the workspace. So you can have a standardized way of enforcing pull requests across the whole company without having to have every single team managing their own set of these things and implementing them all one by one. The key thing though is that teams will still have the ability to implement their own additional checks if they want to. So these central workspace ones act as a minimum requirement across the whole company, and then teams can implement their own additional ones on top if they want to have team-specific workflows. A really key thing we're trying to achieve with all of this is minimum set of requirements determined by the company, the organization, but not disempowering teams to still control their own workflows. It's really important to us that we maintain both levels of autonomy for both groups. Later on in this webinar, we'll actually be building a really simple custom merge check app live. And so you'll get to see how that all works, and you'll get to see how simple it really is to actually build one of these things and get it working. And again, the slide deck is just going mad. The second major thing that we're going to be talking about briefly is a concept called dynamic pipelines. So dynamic pipelines is not available yet, whereas custom merge checks is in open beta. You can all go and use custom merge checks today, and I'll share some links on how to do that soon. Dynamic pipelines is a concept that we're bringing to the Bitbucket Pipelines product, which will allow you to kind of transform your CI/CD workflows from a kind of static, declarative YAML-only structure where your entire pipeline has to be determined up front and it can't really adapt a whole lot, to something that is smarter and more flexible. Dynamic pipelines use a Forge app. Basically, what happens is when your pipeline is run, the YAML configuration from the repository is parsed into sort of a workflow syntax, and then we send it to a Forge app that you have written and you have developed. That Forge app can then modify or mutate that pipeline in any way it sort of feels like it needs to, based on your business's requirements, your business's workflows. That means that your pipelines can now become much more intelligent. They can change based on context. They can implement business rules. They can do all kinds of things. Some examples of things that they're already being used for internally at Atlassian are things like standardizing CI/CD workflows over the whole organization, automatically generating best practice CI/CD workflows at runtime. So we actually have a system where rather than teams writing the entire YAML file themselves, they just put a few labels in there telling the system what language they're writing in and what frameworks they're using. And the dynamic pipeline generates the best practice pipeline file for them at runtime. So it's always up to date and it's always following our best standards. You can use it for enforcing compliance and security policies like golden images and only allowing builds to be run on certain Docker images that your security team have blessed. And you can even go so far as to use it for things like cost attribution. So you can use it to dynamically assign builds to different runners based on the team running the build, so that it gets assigned to a runner which is, say, tagged with that team's cost center. So you can automatically attribute costs to CI/CD and stuff like that. So the use cases for this stuff are quite literally endless. You can achieve an amazing range of things with it, from technical solutions all the way through to business operational solutions. We're not going to be building a dynamic pipeline today. That's something that we're going to be looking into in a few webinars time. But we will be getting to that once the capability is released. So we're looking to go to open beta with dynamic pipelines. I'm not going to say a specific date, but we're talking sort of less than 3 months in that sort of time window there for dynamic pipelines. And we'll have more specific details on that for you very soon. All right, so the fun part, let's get started. So what we're going to do is we're actually going to build a very simple custom merge check app now. Now, before I jump into that, I'm just going to quickly check the Q&A in the chat. Erin, I don't know if there's anything specifically you want me to address.
No, I think later is fine. So, but yeah, we should make sure we have some time at the end for Q&A.
Yeah, perfect. And anything that we don't get to, we'll make sure we grab all of those, and we'll share sort of a post after this with answers to all of the questions coming through. Different screens, 2 seconds. So I'm going to share a series of links in the chat before I get started. So before I dive into this, there's a level of kind of a little bit of prior knowledge that I recommend everyone have before they dive in and try to build one of these themselves. So there is a sort of a generic Forge getting started tutorial, which is not Bitbucket specific. And that just gives you the basics of sort of setting up the Forge environment on your local machine. It takes probably about 15 minutes to get through. So I'm going to share the link to that in the chat. And then the second thing is there is a Bitbucket Cloud specific, building a Hello World app inside Bitbucket Cloud with Forge. We recommend you go onto that once you finish the Forge getting started. That one's a little bit more in depth. There's probably, I'd say, an hour or two's worth of sort of work in there. But once you've done those two, you're kind of fully up and ready to go. You've got plenty of exposure to different concepts, and you'll be ready to get started. So the app we'll be building now is sort of assuming that you've probably done those first two basic tutorials, which, like I said, is probably maybe 2 to 3 hours of time investment total. And then you're kind of ready to go building a custom merge check. And the custom merge check itself, you'll see, is actually simpler in some respects than the basics of Hello World app. So I'll send a link to the Hello World tutorial. And the app that we're building today, the repository for that will be available. It's fully commented code. You'll be able to pull that down yourself and use that and look at that. You can use it as a basis for your own custom merge checks. We also have a series of other example apps already that are available. And we have documentation, we have some information on custom merge checks. We also have a community space for you to join after this session where you can go and ask questions. The engineering team is in there every day. You can also sort of get to know other members of the community, share ideas, and get ideas for things. So I'm going to share a few more links in the chat now. So please grab those so that you can reference those later, and then we'll get into it. All right. Share my screen again. All right. Ash or Katarina, can you give me a thumbs up if you can see an empty code editor?
Yes.
Perfect. All right. So what you should be able to see here is a lovely empty project. So there's nothing in here at all. So we're going to build a simple custom merge check app with this now. So the first step whenever you're building a Forge app of any kind is to use the Forge CLI to scaffold the app. So Forge has its own CLI, and it's a really powerful tool because it lets you scaffold basic apps kind of automatically. You don't need to add all the boilerplate in from scratch, which just helps you kind of get started. So what I'm going to do is I'm going to go Forge, create.
Edmund, just 1 second. I think you are sharing your messages in the chat to just the host and panelists. So yeah, we will be sharing them. Yeah, we will be sharing them right now, but you probably want to change your setting as well.
I've done that now. Thank you. Appreciate that. So you know it's an actual live webinar and not something pre-recorded. All right. So what I've done now is I've gone to my terminal in my nice empty project and I've gone Forge create and I hit enter. So like I said, this is assuming you have the Forge CLI installed, which you would have done as part of the getting started tutorial. And the first thing it's going to do is ask me to enter a name. So I'm just going to say March 6 Forge webinar. Yes, it is March 6 for I am. Sorry if it isn't March 6 where you are. So starting with a template. So we have a series of templates in here for you to use. And I'm going to go show all because what I want specifically is a Bitbucket merge check template. Now, there are templates for all of the products that support Forge. So there are Jira templates, there are Confluence templates. We're just lucky because Bitbucket is alphabetically first in the list. So Bitbucket merge check is the template that we're going to use. You can see here there's a series of other templates that you can access as well, which can get you started on different types of apps. Okay, my MPI key is no longer valid. That's great. Well, this is a good example. Forge login. I am going to log back into Forge now because I need to. And one moment, I'm going to stop sharing my screen while I do this. Oh, it's always the way you double check everything before the webinar starts, and then there's always one thing you forget. always the way login decides not to work and you least want it to. I feel like we need some elevator music. All right, then I'm just going to go and I'm going to go and create a new API token because apparently this one is not liking me right now. Apologies, everyone. Give me 2 seconds. Okay, back to sharing my screen after that slight little technical hiccup. All right, where were we? So I've now logged in to the Forge CLI. So to do that, just real quickly, you just need to have a API token for your Atlassian account. You put in your email, you put in the token, you hit enter, and it logs you into the Forge CLI, assuming the API token that you're trying to use has not expired overnight. So I am going to go back to where I was up to. So go through the million different failed attempts to log into the thing. And I'm going to go Forge create. Now, it actually did generate me the Forge app, but I think the thing it didn't do was generate me an app ID. So I'm just going to clear that out. And we're going to start again from here with a working API token. So Forge create March 6 webinar, the name. I'm going to go show all, Bitbucket merge check, and now it's going to create me the app and scaffold that for me. So what it's doing here is it's creating the template for the app itself, the code. It's also generating me a Forge app ID, which is the key thing that was missing from just before because I didn't have an API token to log in with. So I will now open up this, and you'll see in here we have March 6 webinar, and we have some files. So we have this manifest file, which basically is me declaring the Forge app itself and how to use it. And we'll go through this in a second. It's generated me a git ignore file. It's generated me a basic readme. It's giving me a basic package.json file, and it's got a source file with a basic piece of code in there. So Forge apps by default are written in Node.js. So that's why you see this package.json file here. The manifest file basically is how you tell the Forge platform what your app is and how it should interact with that app. So it's quite simple, and I'll sort of walk through that here now. All Forge apps have a series of what we call modules. So Bitbucket merge check is an example of a module. A dynamic pipeline is another example of a module. There are lots of different types of modules. Each UI extension point is its own module. Within that, you kind of declare the basic kind of outline of your app. So it has a key, which is basically just a unique identifier for it. So this is the March 6 webinar merge check. You basically declare a function that this check is based on, which you can see down here. I said is this one here. So this function has a key of main. And so when I reference a function as main up here, it's basically saying this merge check uses this function here. It has a name, which is going to be shown inside the UI. So I can now sort of make this a bit nicer because that's going to be human readable. And then it has a description as well. So this is a Bitbucket merge check example. So I'm going to say a Bitbucket merge check demo app. And then finally, for merge check specifically, you have this concept of triggers. A trigger basically is you declaring when you want this merge check to run as part of the pull request process. So today there are 2 triggers for merge checks. We'll be adding several more in the next few weeks. So the 2 that are available today are on code pushed, which basically means the check will run every time new code is pushed to the pull request. And the second is on merge.
Hey, Edmund.
Sorry. Yes.
One second, sorry. Can you make the editor size bigger? Yes. And everybody wants to know which IDE you're using. So like, we must know now. Yeah.
Okay. Yeah, I get the question. So I'm using WebStorm. Sorry, Ash, go ahead.
So to increase the view size, there's a view option on the top of your screen. If you click that and click original size.
Just the code.
Not for you, and this is for everyone else.
Sorry.
So there's a view options drop down up on the top, and then if you hit 100% on that, you'll see a bigger screen on your window.
Yeah, this is the downside to having a 5K monitor is when you share screen, it makes it really small for everybody else. So apologies about that. Hopefully the code is a bit easier to see now. And to answer the other burning question, so I'm using WebStorm. This is basically the IntelliJ of JavaScript. I'm a product manager, not an engineer, so everything I do is always in JavaScript. I like it. It's good. You can use Visual Studio Code, of course. You'll get all the same capabilities in Visual Studio Code. I like WebStorm personally. All right, so let me continue with this. The last thing I was quickly talking about is triggers. So there are two triggers. On code push will run every time new code is pushed to the repository, and on merge is actually kind of quite an interesting type of trigger. So on merge basically will run these custom merge checks as part of the merge process itself. And this is a really valuable capability if you want to ensure that a certain condition is true at the moment code is being merged, rather than sometime before the code being merged. If you think about kind of merge check implementations that you might see in other products or even in Bitbucket Cloud, all they can really tell you is that the condition was true at some point before you merge the code. Can't really tell you that the condition was true on the moment you merge. The capability to do a custom merge check on merge gives you that capability. So I'm going to change this to an on merge trigger. There. Now I touched on the function before. So basically this is just me declaring a function, which is a standard Forge kind of concept. I give it a key and I give it what's called a handler. By handler, what I'm saying is go to the index file inside the source directory and call the function called run. That's all I'm doing here. It's actually quite simple. So I go to this file, there is a function here called run. Now I can change this to something like custom merge check. It's no issue at all. I just get that and I have to make sure I go back to the manifest and I say rather than going index.run, I go index.custom merge check and I save it. And then finally down here is an app ID. This is unique to every single app installation. So you will not be able to use this app ID because it's locked to my user. When you run the Forge CLI to create your own project, it will generate you a unique app ID here. Okay, so that's the high level overview of the manifest file. Now, what I'm going to do is I'm going to go to the index file. So this is actually a fully functional custom merge check. Yes.
Edmund, it looks like the font size is, yes.
It keeps going small and it's annoying me.
Maybe it depends on the type of file on the extension.
I think it's set per file. So I'll just remember to zoom in when I go to different files. I'm only going to be working in these two files, so I think we'll probably be good now. So you see here, this is 6 lines of code, and although very basic and doesn't really give you much value, this is a fully functional custom merge check app. This will work. It won't do much, but it will actually work and it will give you a result. So I will show you that now. So what I'm going to do is down in the terminal, and apologies, I don't think I can make, I can make this a bit bigger. There we go. I'm going to go Forge deploy. So this is going to deploy my newly created, no, it's not. I'm in the wrong directory. Yeah. Look how lovely and explanatory these errors are. That's exactly what you need to do as long as you're paying attention. Now I'm going to go Forge deploy. So what this should do, if I haven't forgotten anything else, is take the app that I've got here. It'll run some linting over it. So if you've forgotten to do anything or you're missing anything, we have a linter built into Forge that will tell you what you need to do. And it will basically tell you as part of this deployment process, hey, you've forgotten to add a permission to the manifest or something like that. Please go and add that. It's then going to package up the app and it's actually going to deploy it to the Forge platform itself. Once it has deployed, I will then need to install that app into a workspace. So I'm going to forge, install. Now it's going to ask me which product I want to install it to. I'm going to go Bitbucket, and I need to enter a workspace URL. Now I'm going to just stop sharing my screen for 2 seconds because I'm actually using a separate workspace, one dedicated for this demo, and I don't share the full URL for it. So give me 2 moments. Basically, your workspace URL is just bitbucket.org/ and then your workspace name, which is the first section of the URL. And go share my screen. So didn't miss much. Basically, I put in the URL, I hit enter. It asked me if I want to confirm the installation, and I said yes. Now you will need to be a workspace admin to install apps into a workspace. It's a really important point to know. So anyone can build Forge apps, but installing them into a workspace, it does need administrator privileges because apps do have a set of permissions all of their own, so they can interact with repositories and they can make API calls that have been declared in the manifest. So they need to be installed by a workspace admin, which is why I needed to use a separate workspace because I'm not an admin of the entire Atlassian workspace, strangely enough. So now what I'm going to do is that should now be deployed and installed. So let's go and have a look. I'm going to swap over to my browser. And I'm in a repository right now. I'm going to go to repository settings, and I'm going to go down to custom merge checks beta. Now, if you don't see this custom merge checks beta here, it means that your workspace hasn't been opted into custom merge checks. To opt a workspace into custom merge checks, you just go up to the settings button, you go to the workspace settings, and you go down to custom merge checks, and it's just a toggle here to opt the workspace in. This is just a toggle that we've added here while the feature is in beta, so that if you want to disable it for the workspace, you can. It is not opt-in by default, so it's turned off by default, but just go to the workspace settings and turn on custom merge checks if you want to get started. So I'm going to go back to my one Zoom, get everything out of the way, please. Go back to the repository, and we'll go to repo settings. And so under custom merge checks in repo settings, you can see here, I have this awesome little March 6 webinar web check. So this is the Forge function that I just built and deployed and installed. I can now enable this. I can either enable it for all branches, or I can enable it just for the main branch on the repository. And once it's enabled, it will be applied to any pull request that is sort of run against this, this repository. I've got another merge check in here from a different Forge app. I'm going to turn that off for a second, disable that. I'm going to go back, and I'm just going to make a sort of random change in a file real quick, and then I'm going to commit that, and then you can see what that looks like on the pull request. So I'm just literally typing the word random change into a README, and don't worry that it's not a real AWS secret. That was me testing an AWS secret scanning check that I built a couple of days ago, which did work, just by the way. It's actually quite cool. Commit that. I'm going to raise a pull request. I'm kind of skipping through this because this is not actually part of checks or Forge. This is just standard Bitbucket Cloud pull request functionality. And then what you can see is up here, we have this new panel, custom merge checks. So it says 0 of 1 custom merge checks. And you get here, March 6 webinar custom merge check, which is the name I declared for this custom merge check in the manifest file. And if I hover over it, it provides you some information, like saying it will run on all branches, when the last time it was run was, which was never. And then what I can do is I can test this. So this is an on merge custom merge check, which means that it will only run when I attempt to merge the pull request. So if I hit merge and I go merge, you will see that this merge is in progress. You can see this guy is now spinning and the merge failed. And that's expected because the template custom merge check is one that is designed to fail. Basically, it returns a failed result by default. So I hover over this, it says it's failed, which is what we expect. And there's a message here, which is pull request number 10 is not ready to be merged. So if you're wondering where this comes from, this is actually being dynamically generated by the custom merge check itself. So I will quickly swap back to my editor. And you can see here that this custom merge check returns this object, which says success, false. So we're going to fail the custom merge check. And there's a message, pull request number event.pullRequest.id, which is the ID of the pull request, is not ready to be merged. So you can see here, this message is dynamic. This dynamic message is a really powerful capability because it lets you give feedback to the user when a custom merge check fails. So if you have a business process that you're implementing as a custom merge check, and you want to tell the user, hey, you haven't completed this process, but here's how you can complete that now, you can actually dynamically put a response in this message, and the user will see that in the Bitbucket Cloud pull request UI. And now one thing you'll notice is that we didn't need to add any UI components to our Forge app. We didn't need to do anything like that. It's all provided natively by Bitbucket Cloud. And this is what I meant by one of those kind of slightly more opinionated implementations of Forge, where you just have to do something really simple like write a function like this, and we kind of look after the rest for you. You don't have to write any UI. You can add extra UI if you want to, but you don't need to. You can literally write 6 lines of code to get a very simple custom merge check working. So, all right, let's make this a little bit more useful. So what we're going to do is we're going to create a custom merge check that implements a very simple use case. Again, not something that you would probably do yourself, but it's designed to be simple for the sake of example. We're going to implement a basic draft pull request custom merge check. So the custom merge check is going to basically look at the title of the pull request, and it is going to say whether the title contains the word draft or not, and then use that to control the merge. So I've got the code for this already written, and it is available in the repository that will be shared at the end of this session. So I'm just going to copy and paste that over into this file. It is a bit, so once I've copied it across, I'm going to walk through it and sort of explain what I'm doing at each step. The code is also quite heavily commented. So when you go and pull down the example repository yourself and sort of play around with it, you'll know exactly what's going on because it's quite detailed in the comments, and you can understand what's happening as you go. Time it. All right, now let me just quickly make sure this is all going to plug in. Custom merge check is the name of the function. It's in the index file. If I go to the manifest file, we've still got index.custom merge check, so we should be all good. Now I'm going to change this name to draft pull request. And Edmund check demo app that checks if a PR is in draft. And then I'm just going to add another trigger here. So I'm going to add on code pushed so that we can rerun this check when code's being pushed as well. Save that. And then I'm going to walk you through this index file really quickly. So I've added in some libraries here that I'm using. And I've got to the file. I'll tell you what those mean in just a second. There we go. So this is a library that is made available by Forge itself. So this is basically the Forge API library. There's a series of other Forge libraries that are made available that you're able to install into your app and use. And this just gets rid of a lot of the complexity because you can reuse reusable bits of functionality like calling the API, using a route argument. And this is what allows you to kind of bypass the need for implementing your own authentication, because we do all of that for you as part of this library. And I'll walk through how that's used in a second. The second one, I mean, honestly, you can kind of ignore that. That's just an object that I created that holds a pull request. It does nothing. It literally is just an object with some properties so that you get some nice autocomplete when you're typing in your IDE. So ignore the rest of that. You don't need to have this. You could literally just call the API and get a pull request object. It will do exactly the same thing. I just added this here because it makes the developer experience a little bit nicer because you get autocomplete on properties when you're accessing it. So I'm going to run through this now. So we're just running a log. We're telling it that we're checking for draft pull request. First thing we need to do is we need to actually get the full details of the pull request. So when a custom merge check runs, you get some basic information about the pull request that it's running against. For example, the workspace ID, the ID of the repository it's running in, and the ID of the pull request it's running in. You don't get any more information than that. And that's done on purpose so that when you need the extra information, you call it yourself from the API, and you know that you're always getting sort of the freshest set of information about each piece of data you want. So the first thing I need to do to check if the PR is in draft is I need to get the pull request. To do that, I have this get pull request function that I created, which is just down the page, like 10 lines. That's all here. And this makes an API call to the Bitbucket API to get the pull request. Now you can see this is all white and underlined. It's because I haven't actually installed this library. I've just sort of imported it. So I need to install this. I'm going to go npm install @forge/API to install that package. So npm, if those of you who aren't familiar, is just the node package manager. So it's similar to things like Gradle or Maven or NuGet if you use .NET. It basically is just a package dependency manager for node projects. All right, I've installed that. So now this is no longer highlighted. It's now all green, which means I get autocomplete. And this is a function provided by the Forge API library, which lets you call the API for Bitbucket without having to think about the auth side of it. So you have here API.as app. And what this means is you're using the authentication identity of the app itself. So the app has its own identity in the system, and that's what you're authenticating as. Each app is granted what we call scopes, which basically tells Forge what it has access to on the API, and then tells you as the workspace administrator exactly what that app can access. So you don't need to worry about that in a huge amount of detail. Just know that workspace admins have control over what apps can access, and that is all declared in the manifest file in the Forge app. When you go API.as app, you're calling the API as the app itself. There's also as user, which means you would use the identity of the user that is actually interacting with the app. We're not going to show that today. Request Bitbucket means we're calling the Bitbucket API, and then this is the API endpoint that we're going to be calling. It is a little bit verbose. It's basically just saying call the Bitbucket Cloud pull request endpoint and get the pull request with the ID that came into the check. That's going to be returned. I then just give back a pull request, which comes back up to here. So this is now a fully kind of populated pull request object. And then down here, I have this check PR is in draft function, which again is just down the page a little bit. And all this does is it takes the pull request that I just retrieved from the API. It gets the title property from that, and it just converts it to lowercase, just so that we don't have to worry about casing at all. So I'm just making it lowercase by default. And I basically go, if the PR title includes the word draft, then we're saying it's a draft PR. And I return this object, which basically says, I want to fail the check, and I want to return this message, pull request title cannot include draft when merging. And if that's not true, I want to return this object, which is success. So the check passed, and the message is pull request is not in draft. So that's basically all there is to it. So I am, just to recap, getting the pull request from the API, and then I am looking at the title here and seeing if it contains the word draft. If it does, I'm returning this object. If it doesn't, I'm returning this object. And that is the entirety of the custom merge check. So that's ready to go. Now I need to now deploy this so that it can be used. Now I need to actually do some things in the manifest file here because I'm now calling the API, and I don't declare anywhere in the manifest that I need to call the API. So what I'm going to do is I'm going to go forge lint. And what forge lint will do is it will look at my code, and it will actually tell me, should tell me, it's not at the moment, which is a bit awkward. So check on that. It should tell me that I need to add some API scopes to the manifest file. It might be because it's not checked into Git. What the scopes are basically me just declaring that I need to access some resources in the repository. So if I just deployed this app and installed it and tried to run it, it would not have worked because it would have tried to get the pull request and it hasn't requested that permission. So when I add in this permission section to the manifest file and scopes, it says read repository Bitbucket and read pull request Bitbucket. Basically what we're saying is this app will have permission to read pull requests and to read repositories, which it needs in order to check for the PR title. So now that that's done, what I need to do is go, I always forget this command. Katerina, how do I update an existing Forge installation? I always forget the CLI command for this.
Forge install space -- upgrade.
I think that's it. Perfect. So what that does basically is just reinstalls the app because I've added these new permissions. So it needs to be reinstalled by the workspace admin, which is me. And I'm basically explicitly declaring that I want to allow it to do that. I think I forgot to deploy it before I did that. So I needed to do Forge deploy because I've changed it. I need to deploy the new version. And then I'll need to do that upgrade again because I installed the same app twice. I know we are getting close to time. We are about 30 seconds from finishing. Where is that coming from? Sorry, this is, oh. This is what happens when you have a repository you're trying to use in 5 different places and you're not really good with Git. You end up putting the wrong version of it in places. Ignore that. That's again, just probably a little. That's not going to work again. Stop it. Sorry, everyone. Just to be clear, this is a me mistake, not a Forge mistake. And you get to see me live debugging, which is always a lot of fun. Fingers crossed. Running Forge lint, no issues found. Deploying. Now, one thing I'm not going to have a chance to show you today is the Forge tunnel, which lets you basically do live edits of your code and have it pushed up to the workspace in real time to do like live debugging. We'll go over that in the next session where we're diving deeper into a more complex custom merge check, and we won't be spending the first 20 minutes going over a slide deck. So just finishing this deployment, and then I'll install it, and then I'll show you that updated version in the pull request. Perfect, deployed. So I need to do the upgrade now. And I spelled install wrong. It just asked me if I was sure I wanted to install it with additional privileges, and now it's done. Say that. Now I'm going to jump back to my browser real quickly. Back over my browser, if I go to the repository settings, merge checks, you see here there's the new trigger has been added. So it's now on merge and on code push, and that's still active. And if I go back and I create a new pull request, so I'm just going to do another random edit. Commit, create a pull request, and now I'm going to change this specifically to draft. That was the branch name, not the pull request name, but either way, it'd be fine. Now, what you'll see here, real quickly, see there's 2 different versions of the custom merge check. So one is going to run on merge and one runs straight away. The one that ran straight away passed because when the pull request was created, the title did not contain the word draft. Now, if I go and add draft PR, save, merge. Now, just quickly, this will actually merge because I'm in a non-premium workspace. So non-premium workspaces at the moment, merge checks show up as a recommendation, not like an enforced thing. But I'll be able to show you the failed merge check once I hit this. And it says merge failed. And you can see that. This one failed because at the time when this one ran, the PR title did include the word draft. So you can see here, failed merge check, and this message, pull request title cannot include draft when merging. So that's now, you can see, fully working. This was before when it didn't contain draft, and this is now after when it does contain draft. You can see that it's being blocked. All right, I'm going to stop there with 2 minutes to go. And we'll do a quick round of questions. And then anything that we don't get to, we'll be able to follow up with afterwards. I'm happy to hang around for a few minutes. I appreciate everyone else might not have that flexibility, but I'm happy to hang around and answer some questions as we go. Just to recap also as well, that all the code for that repository will be available for you to all to grab and pull down and use either for just testing, or you can even use it as the foundation for your own custom merge check apps, which you can go and build today.
So Edmund, if you go to the Q&A, we did the voting on the questions. So if you can sort by most upvotes, you'll see that.
Oh, most upvotes, got it. How can the sequence of those apps be influenced? Imagine I have a costly merge check and a cheap one. I would want to run the cheap one first and afterwards the costly one, meaning it takes a long time. Right, so that's a really excellent question. So there's a few ways you can do that. And we're actually looking at adding, I guess, like other ways you could do that in the future. The simplest way to do that would be to use a trigger that occurs later in the workflow. So for example, the on merge trigger is designed to be always like the last thing that runs. So you would probably want to run your cheaper things on code being pushed each time and then run anything that's kind of more critical later on. The other option that we will be looking at, not for GA, but something I'm going to add relatively soon after, is actually having an API that can be called to basically invoke the running of particular checks. So what you could do in that context is have a check which hasn't been triggered and actually call it from your cheaper check at the end of that process. So once you've run your cheap check, that's all passed, you could then make a callback and basically invoke the more expensive one. There's a bunch of other ways you could do this as well. We're going to have the concept of like asynchronous checks where it's like you run a check, it returns a status, which is sort of like pending, and then it can actually call back asynchronously later to update the status. So what you could do hypothetically is like your cheap check could just be one really long asynchronous one. You return a status and then you call the sort of expensive check. And then once the expensive check is finished, it could just call back to us using a short-lived token that would be provided as part of that process to set the status of the long-lived check. So there's a bunch of ways you can solve that problem. We don't, I guess, have like an endorsed way to do that today that we'd recommend, other than just using a trigger later in the process. But we absolutely are going to be catering to that scenario. And once we have kind of like an official supported way of doing it, we will have an example app built and shared that you can use to implement that. As far as I'm aware today, I need to go and validate, but I do think Forge async events is the right word. I do think that can be used, but you can't return a check result from an async Forge function just because of the way it works. Once we add the ability for you to invoke a check from a Forge function, you would be able to kind of use that to close the loop. So you could run a long-running process as a Forge async event. You could then store the outcome from that in what's called Forge storage. So for those who don't know, Forge storage is just a really basic data store, which apps can use. And then you could re-invoke the kind of the quick check to just look at the Forge storage and see what the outcome was. I'm not good. Like I said, there's 100 ways you can do this, but we will make sure that we have a couple of examples of kind of like endorsed ways of doing it as we move forward. Really excellent question, though, and that is something that we've been working on, making sure we have a great solution for. The other option as well that we're looking for, again, not right now, but probably within the next 3 months, is being able to invoke an arbitrary pipeline from a Forge app. So you could actually have a pipeline configuration as like a JSON file inside a Forge app, and you could call an API to run a pipeline that actually runs that configuration. So you don't need to have the pipeline YAML stored in the repo. You would be able to actually run a pipeline that you kind of defined as part of your Forge app as well. So that could be another way of running long-running tasks. All right. Currently, I can't manage my Forge apps through the workspace settings, upgrade, and install. Is there any roadmap when this will be implemented? It's interesting that Forge on Bitbucket lists left EAP status. It doesn't support managing apps. Yeah, really excellent question. So today, managing apps is done by the CLI. Yes, that will be added. To be honest, the main reason it hasn't been at the moment is just because you may or may not be aware that there's work happening around Bitbucket Cloud to more tightly integrate the product with admin hub and things like unified user management. And part of that will be that certain parts of the workspace administration experience will be moved to admin hub. I'm not saying that's going to be happening for Forge, but we just didn't want to go and build a whole front end for managing Forge apps until we knew exactly what was going to be happening there. So now that that's sort of as a bit more mature, you will start to see that being added into the workspace settings relatively soon. Is there any roadmap for releasing Bitbucket API support for Forge platform? I'm not do you mean as in supporting Bitbucket APIs to be called from Forge? I'm going to assume that's what you mean by that. If not, I apologize. And feel free to throw something in chat. So I'd say around about half of the Bitbucket Cloud APIs can be called from Forge today, but there is still quite a large number that can't. We will be fleshing that out over the next sort of few months, with the goal being that I'd say within 3 months, I want to say, that pretty much every API will support Forge. So we added the ability to look up code reports, code insights, code annotations only yesterday. So that will be coming as we go. That's the kind of thing where please jump onto the community site and create a ticket, because we'd love to get feedback from you guys around what things you want to see now versus what's things that you want to see a bit later on. Handling different Forge app environments in a workspace like in Jira or Confluence. Now, if I have multiple environments like development and staging installed, it loads all environments into a single page. I'm going to be honest, I'm not 100% sure what the question is for that. Sounds like it might be more related to like the Forge environment concept in general. So we might follow up on that after this. What are the steps to release a Forge application to the marketplace? Is it the same to release like Jira or apps? So as of like today, Forge apps are not available for Bitbucket Marketplace. That's something we're working on at the moment. So stay tuned for updates on that. Is any roadmap to have paid Bitbucket applications paid by Atlassian? Yes, but I can't give you a specific date at the moment, unfortunately. All I can say is it is actively being worked on. So yes, it is coming. I can't say exactly when. Please stay tuned. Is there a plan to add licensing to the Forge app so marketplace vendors can sell them on the marketplace? Yes. The previous answer on that. Gadesh, will donate pipelines be part of the premium feature, or is this something that needs extra payment? Donate pipelines will be part of the Bitbucket premium tier. So you won't need to pay anything extra to use donate pipelines. Same thing with custom merge checks. So the way custom merge checks will work is you can run custom merge checks if you're standard or premium, but they will only block the merge if it's in a premium workspace. And that is the same way that our branch restrictions work today, where you can run merge checks, but they'll only block the merge in premium workspaces. So custom merge checks will work exactly the same way. For dynamic pipelines, they will only be supported in premium workspaces, but you don't need to pay anything extra, if that's what your question was, Gajesh. And apologies if I'm pronouncing your name wrong. Another one from Gajesh, are there any plans to support writing Forge apps in other languages such as Python? Katerina, you might know more about this than me.
Yeah, I didn't answer this because I was looking for the official answer, and probably you can tell I'm not a PM, so just from this. So to the best of my knowledge, no for Python, but we are looking at other languages right now.
Awesome, thank you for that. This is not sorting by most upvoted. I don't know what.
I think you need to refresh it.
That's interesting. Yeah, I did. That's really strange. All right. James, could a merge check run an external tool such as source code formatter? Yeah, absolutely. So, I mean, again, this is one of those situations where there's a million ways you could do this. So the simplest way is you could call the Bitbucket API, pull the code into the Forge app via the API, run your source code formatter over it, and then push it back in as another commit. So that would work. Another way of handling it is you could use Forge to invoke an arbitrary pipeline, which actually has, say, like a linter or something like that as part of the pipeline workflow. So then you can actually clone the repo in and run that. That would use build unit flow, so kind of same way you might not want to do that. So yeah, there's a bunch of ways you can do that. Another way you could do that is you could actually call an external tool outside of Bitbucket. Short answer, yes, absolutely. Because you can do all of those operations via the API. You can pull the code in, you can create a new commit, you could manipulate the code. As long as you know how to write the logic in your app to do it, there's absolutely no issue at all. And using JavaScript as an example, all the linting tools and formatting tools are just the JavaScript logic themselves, so you could import them and run them. For other languages, the main, I think, challenge you would have implementing that as a Forge app is finding the relevant formatting tool and executing it in a Node.js environment might be a challenge. So in that context, I think your better option would be use the Forge app to execute a pipeline that actually pulls in the native version of the formatting tool that you want to use and makes the changes as part of the pipeline itself, and then pushing it back that way.
Yeah, and I would say, like, if you can share a bit more in the community, and I'm going to repost the link right now, we can keep the conversation like about how to do it, what's the best way of doing that.
Yeah, perfect. So just quick follow-up that you'd want to run Clang format and C++ code. Yeah, exactly. So I think this quickest way to do that it would be to probably run that as part of an app, like use your Forge app, either to, if there's a Node.js implementation, which it's possible, there's a lot of crazy stuff in Node.js, you might just better run it like as part of the Forge app and then just fail it. If there's no Node.js implementation of that particular formatter, then I'd say you want to just execute a pipeline, pulls the code in, runs the formatter, and then returns the result to the check, and then you could fail the check. Is there a plan to add licensing? Already answered that. I can enable the custom merge checks for repos. Will I be able to enable them on the project level for all repos under it? Yes, you will. So the order of, I guess, priority we're going in is repositories first, just because that's kind of a known pattern and everyone's familiar with it. Then we're adding workspaces, because that'll allow you to kind of define company level policies and processes, which we think are really important. And then project level support will be added after that. So you will be able to do it at the project level. refreshing the list. If we create an app, how can we advertise it effectively? Do you have a cooperation with vendors about new Bitbucket apps? I'm assuming this means an app that you are looking to monetize. So we are looking into what the process for having apps listed in the marketplace is today. The goal initially is that you'll be able to list apps in the marketplace, even if they don't support being paid for via Atlassian straight away. And then paid for via Atlassian will come relatively soon. And then obviously we have a lot of programs around partnering with different app developers to sort of co-market and things like that. It's kind of outside my space, if I'm honest. I'm very much Bitbucket focused. So my goal is to get Bitbucket integrated with the marketplace. How things happen after that is probably something that would be best discussed with the marketplace teams. Does Forge, especially custom merge checks, have a max time limit like the Bitbucket pipeline steps? Another excellent question. So yes, but so Forge custom merge checks execute synchronously. So basically we call out to Forge and we expect Forge to return a result directly to us. Today, there's an execution timeout limit of 25 seconds on that. That's obviously quite restrictive. So what we will be looking to add post GA is the concept of an asynchronous check. So you would execute a Forge app that would return basically like a pending state. And then you could use that check to then invoke other longer running tasks, whether that's something like a pipeline or whether that's a third party service. Like you might have a SNCC, you might have a SNCC license that runs a scan on using SNCC. You might call their API and say, hey, here's a commit. Please run a security scan against this and then come back when you're done. That external service can run whatever thing it needs to. It could take an hour. And then they just need to call back to then re-invoke the check to basically be like, hey, I'm ready for you to now conclude. And that check will rerun and will be able to then override its previous pending state to either a pass or a fail. So the way that model will work is kind of a callback model where you will call out to an external system or to a long-running process. And that long-running process will need to call back once it's done and basically rerun the check, and the check will then update its status. So answer is yes, that max time is still there. It's 25 seconds by default, but there will be ways to extend that using asynchronous kind of workflows. What happens to running merge checks while one is doing Forge upgrade? Are those unaffected, meaning running old version? So yeah, okay, great question. So the moment you run the Forge install -- upgrade in a workspace, every check in that workspace is upgraded to the new version. So we've put a lot of work into making sure that the check enforcement on pull requests is, I guess, like completely I don't think the right word for this. It's always enforcing the most up-to-date set of policies and rules that you have implemented. And so even if a pull request was created under an old check version, and there's a bunch of checks that have run with the old version, basically you're always going to get the newest version being applied. So I hope that answers your question. Basically, the new version will be run on the PR as soon as it's upgraded. What is currently the best way to access the repository in custom merge checks without too much latency or straining the low REST API rate limits? An example is code owner solution that needs pull request, diff, and access to code owner's file. Cool. So in terms of the API rate limits, I'm not sure if people are familiar with Connect, the old extensibility framework. The API rate limits on that were extremely restrictive. I won't go into detail, but basically there was like a shared limit across a bunch of different things. The way it works for Forge is each Forge app has its own unique API rate limit. So each Forge app gets 1,000 calls an hour. So that should cover most scenarios. Now we are in the process of looking to increase the rate limits in larger workspaces, particularly. So say if you're in a workspace with say 1,000 users, the API rate limit will be, could be raised. It's not available yet, but it is something that we're looking at actively. I hope we have something in the first half of this year around that. So that will allow larger workspaces to get higher rate limits. As of today, each Forge app gets its own kind of firewalled rate limit of 1,000 requests per hour. In terms of latency, sorry, so latency should not be an issue because realistically, these Forge apps are running in the same environment as Bitbucket itself. So you should be talking like single-digit millisecond latencies. File size could be a thing, maybe, depending on how big the files are, but latency should not be a huge issue. If you're particularly wanting to access code and you wanting to do operations on code, that's where we would recommend calling out to a pipeline and running a pipeline, because that can clone rather than using the API, and the limits of cloning are significantly higher. Does Forge get access to repository variables? Great question. So yes. You'll need to make sure the Forge app has the relevant permissions to do this. So they'll need to be declared in the manifest. So the main use case I'll talk about for this is dynamic pipelines. So the way dynamic pipelines will be able to access the variables, we sort of went back and forth on this a bit on how to support this. Basically, there is actually an API that you can call on Bitbucket Cloud to access repository variables. So you will just call that API from the dynamic pipeline to get them. Now, that's a bit of a kind of heavy-handed way of doing it. So we're actually building a Bitbucket specific kind of like utility library that's going to have a series of helper functions pre-built in it to handle common use cases. And an example of one of those things that we'll just kind of build for you that you can just install will be how to access a variable from a repo. So as part of a dynamic pipeline, you just do something like api.asapp.request Bitbucket, and then you would, you wouldn't even do that. We'd put all that into the function for you. So you'd probably just like pass in the repository ID and then pass in like the key of the variable you want to access, and we would just go and grab it for you and bring it back. Not available today, just to be clear. Stay tuned over, I want to say, the coming weeks, like where a lot of this stuff is going to be hitting the road soon, primarily as we get ready with dynamic pipelines. Is there a way to have a Forge integration talk to a private server not exposed to the internet, for instance, through running the Forge app on a dedicated agent similar to what's offered by self-hosted pipeline runners? I'm going to screenshot this question and send it to some people. Not right now. So there is a concept called Forge Remote, which lets you run the like the lambdas on your own infrastructure. So rather than calling a function, you call a URL. That does still require the Forge platform to be able to call to your own infrastructure to invoke that that function. What we don't have anything for today is the ability for you to have a version of this which basically doesn't require an inbound request. So what you're referring to there with runners is basically you there's a service inside your firewall which calls out periodically and fetches any new events and then runs things based on that and then pushes it back. All I can say right now is this is a friction point we are aware of, and we are investigating ways to mitigate. And I'll also just call back to the start of the session where I mentioned that I also am the PM for the pipelines team, and I'm sure you can put things together. So we're looking into how we can make this possible. I can't promise anything right now, just to be clear. With dynamic pipelines, will we see further flexibility around parallel steps? For instance, the ability to effectively run multiple steps in a single parallel thread. I'm gonna avoid making a comment about. I'm sure you're one of the people that have commented on the B Cloud that you want parallel stages and parallel steps in a stage. Yes is the answer. I want to be clear that dynamic pipelines is not going to solve that problem for you. We're just going to add parallel steps and parallel stages. You'll be able to do everything in dynamic pipelines that the main pipelines workflow supports, and to be honest, a bit more, because you will have a lower level of capability. It will not allow you to create new constructs, although because you have kind of infinite flexibility with dynamic pipelines, I'm sure there are ways you could construct your own kind of version of that. I would not recommend it, just to be clear. The correct answer to this is we are working on adding parallel steps and parallel stages. Parallel steps inside a stage and parallel stages, as well as manual triggering of steps inside stages. Please stay tuned. Maximum runtime of a Forge app currently is 25 seconds. But as I said, there will be asynchronous flows, which will allow you to run workloads that go longer than that. Our org needs to be able to audit all repo events, including a new clone and any patches. It doesn't look like Forge has access to these events through bcloud. I'll have to have a look at that bcloud, James. Basically, what I can say is you could, if you wanted to, listen to Forge events and then use that to write to some kind of audit trail if your organization requires that. It is a perfectly valid use case. If there are particular events that you need to run these on, you mentioned a few here.
Yeah, it looks like it's clones and pushes.
Yeah. This is a great kind of thing. I'd really suggest you go and create a question in the community group, because I'd love to hear both from yourself, but also from other people what they'd like to see. It is absolutely valid use case, and we're looking to add as many sort of Forge trigger events as possible. So you could use it for that purpose. I will have a look at that bcloud later though as well. I will open that now and leave that for me to look at. With dynamic pipelines, will we see the old YAML tooling for IntelliJ updated as well? Currently, things such as fail fast show up as invalid. I will chat to Danil. Danil is the maintainer of the pipelines. I'm blanking on its name. The plugin for IntelliJ pipelines. He actually built it, maintained it. He's in one of my teams. I'll chat to him about that and see what's going on. It's not going to be done as part of Dynamic Pipelines, just to be clear. This is something that Danil maintains as a kind of an innovation project himself. So I'll see what his plans are on that, and I'll follow up that later. I'm very conscious of not wanting to make this a pipelines conversation, so I'm just kind of going through this really quickly. Theoretically, could Forge be used to extend the links in Bitbucket to add additional checks that are currently only possible with local Git hooks for issue keys in Git commit messages? So yes, but again, one thing custom merge checks one thing about custom merge checks to be aware of, sorry, I'm just laughing at Ryan's comment in chat, is that they run post-receive. So custom merge checks do not run pre-receive, which is where a lot of people want to run like custom Git hooks. As long as you're okay with these things running post-receive, so the code's already been pushed to the remote branch, then effectively you should be able to do almost anything, especially when you factor in that relatively soon you'll be able to invoke arbitrary pipelines, which then effectively gives you the ability to run almost literally anything. Like you clone the code, do whatever you want with it. So I'm going to be honest, I'm not 100% sure what you mean by extend the links in Bitbucket to add additional checks. You should be able to achieve whatever you need, though. Sorry, there's a comment under that. Yeah, the post links could be extended to not block. I'll have to have a look into that to check and see what the situation is. So I'll follow up on that and get back to you. These will not block pushing, just to be clear. We are looking at ways to extend what we call the pre-receive process, which is what happens before a push is completed. Anything we do there, just to be clear, will have some limitations on it in that it will only be able to access the metadata of the push. So things like the commit messages, the branch name, the user details, it would not be able to access the code itself, like the diff. There's a pretty fundamental technical constraint around multi-tenanted code management tools that makes it extremely difficult to make the code available in that context safely. So we are looking to make the pre-receive process extendable and implement checks. It is not happening for a while, just to be clear, and it will only be able to access the push metadata, not the code. So things like checking for Jira issue keys, yes, that kind of thing would probably be viable, but things like secret scanning in the code is not something that you would be able to achieve with that. And I want to just really reemphasize, this is not something that's actively under development right now. It's something that we have planned for the future. Hope that answered the question as much as is feasible. All right. I think we're well over time. So I want to thank everyone for coming along and attending. The repository for all of this, I'm not sure if that's public yet.
I don't think so.
Okay, so we're just working on making the repository with the code that we use today public so that you can all access it. We're just going to go through some processes to open it up so that everyone can get access. We'll send out a sort of a post-webinar email with links to that repository. We'll also share some content in the community forum. So again, please jump into the community. Katarina has shared the link in the chat. That's going to be your best place to get updates on all of this. Additionally, just give me 1 second, there's going to be another webinar in a few weeks, which will be diving even deeper into custom merge checks. And I will grab the link for that right now and share that as well. And as part of that webinar, we're going to be looking at building a custom merge check that reads some test reports created by pipelines and then blocks the merge based on whether or not there are outstanding security vulnerabilities on a PR. So sort of going a bit deeper into the weeds and understanding how it works under the hood. Thank you, everyone. Hope to see you all soon. And yeah, jump on community and we can keep the conversation going.
Yeah, thank you, Edmund. Thank you, everybody. Bye.